Okay, let's study the applications of right triangle trigonometry. What I've done is I've got about 6 story problems here, and what we're going to need to do is we're going to need to draw a picture of our situation, fill in the values that were given in the picture, and then decide which trig function will help us to solve the problem, and we're going to solve algebraically. So that's where we're headed with this. So each time I'm going to give you a moment to read the problem to yourself. Or would you, actually I'm going to ask you to hit pause to read the problem. Okay, Mr. Johnson is a jet pilot who just moved his family to suburbia, 26 kilometers from Toledo Airport. So, let's even start getting a picture. Here's the airport, and here's, let's just kind of draw a straight line, and here's Mr. Johnson's home. All right, and it is 26 kilometers from the airport to his home. Johnny would like to see his father's plane as it flies over their new home for the first time today, but there's a layer of clouds at 5 kilometers. Let's just circle that. Will Johnny be able to see his dad's plane if it takes off at a 9-degree angle? So, will he be under 5 kilometers? Because then he'd be able to, if the plane is under 5 kilometers, then Johnny will be able to see his dad's plane. All right, the unusual thing about this is the plane takes off, and I know it's not really the way it works, but let's just assume that the plane actually goes off at a 9-degree angle the whole way until it's over top of the home. Now Johnny's looking directly up, so this is supposed to be a right angle right here. So we're going to put 9 degrees right here as the takeoff. As a car would travel, they are 26 kilometers away, and we want to know the height of where the plane would be. This is going to be my version of the plane. Um, something like that. What would its height be if it ascends at a 9-degree angle and it's 26 kilometers and a horizontal away? So with regards to this angle, I want to find that. What is the name of that side? With regards to this angle, isn't it the side opposite that angle? Then isn't this the side that's adjacent to it, because this is the hypotenuse? So opposite, adjacent. Oh yeah, that's tangent. So I would say that the tangent of a 9-degree angle is equal to the side opposite. I'm going to call the height x over the side adjacent. I'm going to every once in a while refer to a proportion when solving right triangles. So if you put this tangent of 9 over 1, you would now just take 26 times the tangent of 9 degrees to give you 1 times x, which is x. Or algebraically, many of us would just say, let's multiply both sides by 26 to get x alone. So 26 times the tangent of 9. Let's do that. So 26 times the tangent of 9 degrees, and we've solved an application. His dad's plane is 4.1. I believe we're in meters. No, I'm sorry, we're probably in kilometers. His dad's plane is 4.1 kilometers above the house. The clouds are at 5 kilometers, so we didn't really use this data other than to, at the end of the story, say, yes, he can see the plane. All right. This may, I've got about a good 6 story problems, and I really would like to get through all of them in one segment, maybe a little bit longer. This one's pretty hard, drawing the picture. I actually wish it was later in the document. So go ahead and read it. A bullet was fired such that it just grazed the top of a table. It entered a wall, which is 12.6 feet from the graze point on the table, at a point 4.63 feet above the tabletop. At what angle was the bullet fired? Okay, draw a picture. This is real hard. I almost wish we were in the classroom together. So here's my table, and it's sitting on the ground. And here's a wall over here. So I'm going to use green. So, let's pretend somebody's lying on the ground here, and they've got this gun, and they fire a bullet to just graze the table, and it's going to enter the wall somewhere over here. Okay. It entered at a point 4.63 feet above the tabletop. So here's the tabletop, the height of the tabletop. So it entered the wall 4.63 feet above that tabletop. That part's not too difficult. It entered the wall 12.6 feet from the graze point on the table. It entered the wall, as the crow flies, 12.6 feet from the graze point. So it entered the wall right here. This is where it entered. The bullet entered the wall. At what angle, theta, was the bullet fired? Because maybe I got to figure out who fired it based on the angle. You know, this is a police investigation. So I want to know what that angle is, and I know the side opposite, and I know this side adjacent in a right triangle. Opposite, adjacent, TOA. Opposite, adjacent, tangent of theta is equal to the side opposite over the side adjacent. And on my graphing calculator, to find that angle, I have to tell it I want an angle by going second tan of 4.63 divided by 12.60. I hope you're practicing these number punchings. That should give you 20.2 degrees. Okay, let's do another one. Actually, I have a few simpler problems. That one was very hard, drawing that picture. I'm often going to give you the pictures, but in this document, I'm just making you draw everything. All right, so read the problem. Read it twice. The straight arm of a robot is 1.25 meters long and makes an angle of 13 degrees above the horizontal conveyor belt. So let's kind of just show some pulleys here, and there's my... Let's just kind of do that. And then, you know, I have to show this in 2 dimensions. So let's just say that the robot is somehow sitting right here, and the arm is 1.25 meters long and makes an angle of 13 degrees with the horizontal. How high above the belt is the arm? Let's drop a perpendicular to get the height above the belt. So I just formed my right angle. I don't bother with letters in story problems, except for my unknown, and I'm going to call it H for height. I know this angle. I want the side opposite. I have the hypotenuse because it's opposite the right angle. Let's see. Opposite and hypotenuse. SOHCAHTOA. So the sine of an angle is the side opposite over the hypotenuse. Again, when my unknown is upstairs, it's much easier. Essentially, I multiply both sides by 1.25 to get h alone. And you'll take on your calculator 1.25 times the sine of 13 degrees, and you'll find out what h is. And I found that h is equal to 0.281. And let me see, the units here are meters, so make sure to give me that meters. All right, let's do another one. Of course, you can be pausing anytime. Again, read the problem, read it several times. An observation deck at the CN Tower in Toronto is 447 meters above the level of Lake Ontario, which we're going to kind of say that that's where Niagara Falls is going. So here's my CN Tower, and it's actually, CN Tower is a little bit taller, but the observation deck is right here, and it's 447 meters is where the observation deck is. An observer measures the angle of depression of Niagara Falls to be just 0.37 degrees, not even 1 degree. So you're standing up here, and I can't draw small enough, but you're standing up here and you're looking down towards Niagara Falls, clear day, and you can see it. So this is Niagara Falls over here. My right angle is right here. There's my right angle in my triangle. Let's see. The angle of depression from my eyeballs is, if I was looking out horizontally, I only have to look down 0.37 degrees to see the falls. This is the falls over here. All right. So some people think that this angle right here should be 0.37 degrees, but actually it's 90 minus 0.37 degrees, which is 89.63 degrees, I think. It's this angle over here that is 0.37 degrees, because these are alternate interior angles, because these are parallel lines intersected by a transversal. So an angle of depression means the angle over here is the 0.37. How far is Niagara Falls from Toronto? So here's Toronto. Here's Niagara Falls. I want to know what this is right here. I want to know that distance right there. So let's see. I'm going to use the 0.37 degrees because it's kind of a weird number instead of the 89 degrees. Although using the 89 degrees would put my unknown in the numerator, but now let's stick with this. So given this number, I know the side opposite and I want the side adjacent. Opposite, adjacent, tangent. The tangent of 0.37 degrees is equal to the side opposite over the side adjacent. When that unknown is downstairs, be careful, move algebraically, move x over here, move that down here. So to solve for x, you're going to take 447 and divide it by the tangent of 0.37 degrees. And when you do that, you're going to find out that that distance is 69,218 or so, maybe 19 meters, which is 69.2 kilometers, and I converted that into miles. That's about 43 miles. So that's, I actually have been, you can drive from Toronto to Niagara Falls pretty easily in a under an hour or so. Okay, so it makes sense. All right, let's look at the next one. Again, going to try to get all these in one segment. So you've read the problem, you've read it twice. On a test flight during the landing of the space shuttle, a ship was 320 feet above the end of the landing strip. All right, 325 feet. Let's go, 325 feet. And this is going to be my ship's going to look a little bit different this time. I'm going to kind of show flames coming out of it or something. It's a space shuttle. But, you know, I don't know anything about that. It came in at a constant angle of 7.5 degrees with the landing strip. How far from the end of the landing strip did it first touch down? So, you know, it's coming in like this, kind of like a plane. When it's the shuttle, it's got to come in softly, if you will. So here's my right angle. I got to tell you, tons of people want to put the 7.5 degrees right here. That's not appropriate. If you put the 7.5 degrees right there, then you would have the space shuttle diving into the ground and crashing. And, you know, we'd have a big explosion. The 7.5 degrees is not right here. It came in with an angle of 7.5 degrees. It's kind of that angle of depreciation again. It came in with an angle of 7.5 degrees. So the 7.5 is over here. I want to know how far from the end of the landing strip did it first touch. So I want to know this. It's going to touch right there. Right there. So I want to know x. And I'm going to use tangent again because the tangent of 7.5 degrees equals the side opposite divided by the side adjacent. And again, a little switcheroo. So x would be found by taking 325 divided by the tangent of 7.5 degrees. And when you do that, you get 2,468.6-ish. And let me see, the units are feet. Okay, I hope I can get away with a long video. This one's pretty challenging. Of course, you can stop any of these at any time. Tabletop is in the shape of a regular octagon, 8 sides. Oh, this is going to be hard to draw. Let's try. 1, 2, 3, 4, 5, 6, 7, 8. Kind of like a stop sign. The greatest distance across, or what is the greatest distance across the table? Greatest distance across the table if one side of the octagon is 0.750 meters, just one of these sides. Whew, this is a hard problem. Here's what you got to do when I give you shapes that are regular shapes like octagons. An octagon has 8 equal sides. So I'm going to put radii into this shape to divide, to start finding some angles, because I need angles. I can't just have a side. So in these 8 triangles that I just created, there's 360 degrees in a circle, and if I divide that by 8, I find out that any of those central angles is 45 degrees, I believe. Yeah. So this is 45 degrees. That makes any of these exterior angles in these triangles. 180 minus 45 is 135 degrees, and when you divide that by 2, any of those would be 67.5 degrees. So I'm getting some angles, finally. In order to get this red line, I'm thinking I better get a half of it from here to here and then double it to get all the way across. And so what I'm going to do is I'm going to take this triangle and drop a perpendicular right to there in order to have a right triangle. I'm now going to snag that right triangle out of the picture and fill in the numbers a little bit more carefully. So in that right triangle, this is 67.5 degrees. So this is 22.5 degrees, or half of the 45. This side right here, this side right there is half of 0.750. And if you take half of 0.750, you get 0.375. Whew, okay. Now remember, I'm wanting to find this hypotenuse in this right triangle. I want to find that hypotenuse. Doesn't matter which angle I use. I had to calculate either of those. I chose to use cosine. So I used the 67-degree angle. So you got to be careful here. I'm going to say that the cosine of 67.5 degrees is equal to the side that's adjacent to it divided by the hypotenuse. And so to find the hypotenuse, you're going to type in your calculator 0.375 divided by the cosine of 67.5. And when you do that, you're going to get 0.9799. Remember, that's this hypotenuse. That's this right here. You have to multiply that by 2 to get the greatest distance across the table. And when you multiply that by 2, when I round that off, you'll get 1.96 meters. All right, applications are the best part of trigonometry in terms of right triangles.